In this video, I'm going to show you how to differentiate complicated functions using the chain rule. The chain rule makes it easy to differentiate any function which we can write as a composition of simpler functions. And the chain rule just says that the derivative of a function, f, which can be written as f of g, is just df dg times dg dx. It really just says that df dx is kind of like a fraction, in that we can multiply and cancel out the dg's. And this chain rule is so important. It's going to come up all the time. So here's a big box to indicate how important it is. Here is an example of the chain rule in action. So we're going to use the chain rule to differentiate this function, the square root of x cubed minus 1. And this function is difficult to differentiate because if we tried to do this just normally, then what would we do first? Would we differentiate the square root part or the polynomial part inside? How would that work out? Well, it's not really clear. So we have to use the chain rule to make this problem a little bit simpler. So remember, the grand formula for the chain rule is just df dx equals df dg times dg dx. So our first step, in order to use the chain rule, we need to figure out our functions f and g. How do we do this? Well, we've got to write this function f of x as a composition. Alright, so our first step, we want to write f of x as some function f of a different function, g, so that f and g are both simple functions. So let's start out by figuring out what g is. To figure out what g is, we're going to look at our x term in the function, and then we're going to try to lump as many other terms in with that term while maintaining that g is a simple function to differentiate. So starting with x is simple, x cubed is also simple, x cubed minus 1, that's also simple, we just use the power rule. But then once we get the square root, that's where things get kind of messy. So we're just going to say that g is this part, x cubed minus 1. And then we're going to choose f so that it matches up with our original function. So we want f of g to be our original function. So that's what we do to the x cubed minus 1 part. We just take the square root here. So f of g is just the square root of g. We can double check ourselves too. If we were to plug in g into this expression for f, we should get our original function. And indeed, that's what we get, square root of x cubed minus 1. Great. But the chain rule talks about the derivatives, df dg and dg dx. So now that we've got our functions, we still have to differentiate them. These functions are both simple functions, so their derivatives are straightforward to compute. dg dx equals, just by the power rule, we've got 3x squared, and the minus 1 goes away because that's just a constant. And then df dg equals derivative square root g, well that's just 1 over 2 root g. And so we should really have our final answer in terms of x. We won't want this g here at the end, but for now let's just forget about that. We'll write our final answer in terms of x all the way at the end. Okay, so now step 3 is to actually use the chain rule. We had it written down before, but now we actually get to plug in our derivatives here into the chain rule. So we've got df dx equals df dg, we found down here, that's 1 over 2 root g. And then dg dx we've also got down here, that's 3x squared. Okay, so now we'll go ahead and simplify that a bit. df dx equals 3x squared over 2 root g. All right, and now our last step. Remember, we want our answer in terms of x, so we want to get rid of this g. We want to write our function df dx. We want to write in terms of x. So how we do that is we just need to substitute for x here, so we don't have the g anymore. And to figure out what g is in terms of x, well, we already have that. That's our function definition right here. So then we've just got df dx equals 3x squared over 2 square root of our function definition for g, which was x to the third minus 1. And there we go. There is our derivative of that complicated function. Here's another example of the chain rule in action. And I've just written out our template from the previous slide. It's got all the steps here, but we just have to fill in what each step actually is. So first of all, why do we use the chain rule on this function? One option would be to just multiply it out 4 times and then just get a polynomial and then apply the power rule. But that would take a lot of work. And like, imagine what if this exponent were like even higher, like 99 or something? That would just be a pain. So we're going to learn how to do this quickly using the chain rule. So our first step, we got to write our functions. We got to get our functions f and g. We have to write this original function as a composition f of g of x. And for g of x, we're going to start with just x, and then we're going to look and see how many terms we can lump into here without it getting too complicated. So x is simple, x squared is simple to differentiate, x squared plus 3x, that's also simple. Once we raise it to the 4th power, that's where it gets a little bit tricky though. So we're just going to take this x squared plus 3x, and that'll be our g of x. And then f of g is what we do to that expression, x squared plus 3x. And we just raise it to the 4th power. So f of g is g to the 4th. Now let's double check ourselves. Let's make sure that when we sub in x squared plus 3x for g here, we get our original function. That's just raising this to the 4th power, and yeah, that's what our original function is. Okay, great. So now we're ready to go ahead and take the derivatives of these two functions. So dg dx, using the power rule, that's just 2x plus 3. And then df dg, using the power rule, that's just 4 times g to the 3rd. Okay, so now we can go ahead and substitute those into our chain rule expression. So we've got df dx equals df dg, that's just 4g to the 3rd, and then times dg dx, that's just 2x plus 3. Okay, now we're almost there. It's just this g term here, we need to write that in terms of x so that our final answer is just has x as the variable. So let's write this answer again, except substituting in our expression for g here. So then we've got 4 times that expression, x squared plus 3x to the 3rd, and then times the last term, 2x plus 3. And there we go. That is our final result. That's the derivative of that complicated expression without even having to multiply it out at all. In the future, we'll also learn other ways to make it easier to differentiate complicated functions, including a rule for differentiating a product of functions.